Okay, Dr. Nadiah is from Department of Process and Food Engineering, Faculty of Engineering, Universiti Putra, Malaysia. And for her qualification, she got Bachelor Engineering from Universiti Putra, Malaysia, and then followed by Master and also PhD Food Engineering in the same university. Okay. And she has many scientific experience and specialization from Prime Darby Plantation, and then Halal Product Research Institute, SMS Well Beverage, and Nestle Malaysia. Okay. And we also have, yeah, we will, okay, see, then, okay, this is the Hour End Awards. I see that Dr. Nadiah has many honors and awards. She got many publications. This is around 27, I see, in reputable journal. And we can get a lot of information related to the emerging and non-thermal and thermal technologies. Okay. This is proceeding and conference, and also for the research grant, many research grant here. Okay. And Dr. Nadiah, her expertise is in food engineering. Her research interest is mainly about non-thermal food processing and preservation, food engineering, food analysis, and also computational food design. Okay. Now allow me to welcome our speaker, Ms. Dr. Nur Nadiah Abdul Karim Shah, to deliver her presentation. And I hold you quite long, Ms. Nadiah. The time is yours.
All right, thank you very much, Ibu Asri. Everyone can hear me well? Semua boleh dengar ya?
Yes, semua.
Yeah.
Terima kasih. Okay, let me share my presentation. Hold on. Sayang. Okay. All right. So, selamat petang, everyone. Here in Malaysia, it's about 2 p.m. On a Friday afternoon, and it's quite hot for the past few days. Agak bahang kalau kita sini panggil. Jadi, mostly kita banyak stay indoor at the moment, and I hope you guys are well too. How the weather in Indonesia at the moment, Ibu?
Sangat cerah, Bu. Jadi
sangat cerah, sangat
hot.
panas lah, very hot. Yes.
Yeah.
I think everywhere, especially in the equatorial countries, we are experiencing the same weather at the moment. Okay. I have here about 70 slides, and I hope to finish it by 2 hours. If you have, any one of you have any question, you can write in the chat box, or maybe you can ask me later during the Q&A session. Okay, I will be giving my lectures in bahasa English, or maybe at times if I would like to discuss more, then maybe I will use bahasa Melayu if that's okay with you guys. Okay, all right. Just for an introduction, so my name is Nur Nadiah Abdul Karim Shah. You may call me Ibu Nadiah, it also can. Okay, I will be giving you guys 2 weeks lecture, which is on this Friday on the 12th of May, and next week on the 19th of May. And then we will have a class presentation on the 9th June. Okay, so you will have about 2 weeks break, and maybe you can work on your class presentation. We will discuss more on the presentation later. since Ibu Asri has already introduced me, so I don't need to introduce you anymore. But I would like to say to explain that my area of specialization during PhD is non-thermal food processing. But since then, I have a lot of research also on the innovative thermal processing also, namely in the ohmic heating and also the infrared heating. Okay, so the learning outcome for today, learning outcomes for today is for you guys to be able to differentiate between thermal and non-thermal processing, and to also evaluate critical parameters in thermal and non-thermal technologies, and how does the successful implementation can be done in producing safe food. Okay, we will also discuss on the conversion of conventional food processing technology and how to incorporate non-thermal or the novel thermal food technologies later on during our class presentation. Okay. My reference are mostly these 3 books. Okay, I've used these 3 mainly on the Handbook of Food Preservation, the one in the middle. This one was edited by Muhammad Shafiur Rahman. It's quite good, and the book does not focus solely on the non-thermal, but also on the novel thermal food processing. Okay, so you guys should check it out if you have the chance to find this book. Okay, all right, so just an introduction. Food processing engineering comprises a series of food operations traditionally applied in the food industry. One major component of this operation is relating to the use of heat, and directly and indirectly. So the sole objective is to provide food that are free from any microorganism that may inflict you illness later on. Okay, so traditionally we have been using thermal. We have been using heat to control microbial population. But as we all know, that by using heat, we can also affect the biochemical composition of many foods, resulting in losses of quality, both in sensory and also nutritional qualities. So the last 3 decades, we have seen a lot of advancement in food technology and adaptation of several processes and techniques that are aimed to produce microbiologically safe food, but with minimal alteration to the sensory and also on the nutritive properties. So some of these techniques have eliminated totally the use of thermal component in the food processing, so they are considered to be an alternative method. Okay, so before I go on further, let's look at the history of food processing. The origins of food processing may be placed in ancient Egypt, in that period where diverse developments seem to symbolize the history of culture of mankind. Okay, so crude processing methods that included slaughtering, fermenting, sun drying, and even preserving food with salt or garam are evident not only in the writings of the ancient Egyptian, but also in the Greek, Chaldean, and also Roman civilization. The modern food processing technology was largely developed later on in the 19th and also the 20th century, mainly to serve for military needs. Okay, at that point, we were experiencing, the world was at that time looking into World War I and World War II. So with that purpose in mind, they need to provide safe food for their military, for them to safely go into the war zone. Okay, so pasteurization was discovered by Louis Pasteur in 1862, was a significant advance in ensuring microbiological safety of food. Okay, so during the 20th century, during that time, the world was experiencing World War II, and you also seen the space race against United States of America and the Russian countries at that time. and the rising consumer society in developed countries contributed significantly in the growth of food processing, with such advances such as spray drying, juice concentrate, and also freeze drying, and as well as the introduction of artificial sweetener, coloring agents, and food preservatives. By the late 20th century, products such as dried instant soup, reconstituted fruit and juices, and self-cooking meals were developed. In the Western Europe, and especially in the North America, the second half of the 20th century witnessed a rise in the pursuit of convenience. Everyone wants convenient food at that time. So ready-to-eat meals were often being sold or being marketed, especially to the middle-class working wives and mothers. So using the perceived value of time that appealed to the post-war population. So nowadays, the processed foods that are on the shelf of your grocery shop or supermarket are modern processed foods, or even the traditional ones. But their manufacturing technology, the process control, the packaging methods have advanced and rationalized to an incomparable extent in recent years. Okay, so as a result, products with high quality and uniformity are now being manufactured based on the advancement of food science, applied microbiology, mechanical engineering, chemical engineering, and some other interrelated disciplines. And the food processing industry is one of the largest manufacturing industries in the world, and it possesses undoubtedly a global strategic importance. Okay, everywhere now you are hearing about food security, especially after the post-COVID issues. Okay, it has a critical need. Okay, so everybody eats every day, sometimes more than 3 times a day. So food is very crucial in the growth base of the future research direction, okay, detected by integrated interdisciplinary approach to problems in food process engineering. So in this sense, food process engineers all around the world are faced with the common problem of finding a compromise between the severity of the processes and mainly used as the preservation techniques, and also the quality of the final product. Okay, so basically everyone wants to find a balance, okay, balance between producing safe food, but of course with the quality of the natural food. Okay, so normally the severity of the processing and overall quality is of course inversely proportional. Okay, it's either you get a very safe food but with very low content of nutritional values, or you have a very high nutritional values but not as safe. Okay, so finding the above mentioned compromise is a very difficult task. Okay. So let's look on the food preservation. Okay, so the severity of thermal processing, as you could see at the picture on the left, is normally expressed as the temperature and also holding time, which is directly proportional to the safety but indirectly proportional to the quality as a whole. So principle of chemical kinetics dictate that the reaction velocity roughly doubles with the temperature increase of 10 degrees C. So if you were thinking about cooking your food, so at every 10 degrees C increment, you would have your quality to degrade with 10 degree decrement. Okay, so the number of biochemical reactions triggered by an increase in temperature in food processing will cause irreversible effects and on the nutritional and sensory effects of the food being processed. Right? So what do we do? So what we as a food technologist or as a food engineer, what do we do is we come up with new ideas on how to produce safe food, but at the same time maintaining the quality of your food. It needs to taste the same, it needs to feel the same, it needs to smell the same, it needs to even have the natural quality of your food. So let's say if you're eating oranges, your fruit juice should taste the same. All right, so that's what we are doing. So pasteurization, sterilization, and also evaporation can be considered as unit operation of wide application in different industries, and such they rely on a lot on the chemical engineering fundamentals. Okay. So if you take a look at food preservation, so mainly there are 3 of them. Okay, so you would have inhibition, how to inhibit microorganisms to grow from growing on your food, or how do you inactivate, or how do you kill them. Another method is basically killing them totally. Okay, so one of the inhibition methods is basically using low temperature storage. You reduce the water activity of the food. You decrease the oxygen that the microorganism lives on. Okay, so you increase carbon dioxide. Maybe you can use acidification, fermentation, but I think the most importantly is how you inactivate your microorganism. Okay, so there are various of ways on how to do that. So one of them is sterilization, pasteurization, irradiation, electrifying, pressure treatment, blanching, cooking, frying, light, sound, and magnetic field. All right. So what is sterilization? Sterilization is actually a process to remove or destroy all viable forms of microbial life, including bacterial spores. So we use what we call a food safety objective approach. The advantages of it is you get a long-term preservation with a commercial sterility, so that the packaging and the storage environment will prevent growth of microorganisms of public health concern and spoilage type. Another method is what we call pasteurization. Prior to 2002, FDA considered thermal treatment as the only pasteurization method. Okay? FDA would not allow any non-thermal processing technology or even novel thermal technology to promote its treatment as a pasteurization process. But since 2004, the USDA, National Advisory Committee on Microbiological Criteria for Food, redefined the term pasteurization. So what they redefine is that any process, treatment, or combination thereof that is applied to food to reduce the most organism of public health significance to a level that is not likely to present a public health risk under normal condition of distribution and storage, meaning they approve the use of non-thermal processing technology. But again, we often wonder, why do we need the advancement of food processing technology? Why? Nowadays, I looked at it as the changing of culture, the changing of how we live our life nowadays. Okay? For instance, we have higher income nowadays, urbanization, more people are living in the cities. We also have demographic shifts and improved transportation, which means that we can import and export our food products from United States, from everywhere in the world, that can reach within a day or two in our own countries. And also another important aspect is that the consumer perception regarding quality and safety that are changing the global food consumption. Okay. And also most importantly, healthy, safe, and less processed food are in demand nowadays in today's society. So we would like to see more of our food that maybe doesn't look like this, but still tastes like its original content. So that is why we come up with a lot of technologies nowadays to preserve this. Okay. So heat treatment has been known to have adverse effects on food, which is the change of color, flavor deterioration, decline in nutritional quality. And of course, we have to look at the sensitivity of our food towards heat. Okay, so if you look at this, insects would have high sensitivity, microbes, food plants, seeds, and of course, you look at the tolerance of it. So the tolerance of thermal is very low for insect and so on until the grade. Okay. So hence, why the recent interest in non-thermal technologies? Because not just limited to obtaining high quality food with fresh light characteristics with enzyme and microbial inactivation efficiency, but to also provide food with improved functionalities. We are looking a lot into functional food nowadays. So a lot of these new technologies can improve on that, on the extraction of the functional qualities. And encouraged also by the environmental friendly and also cost efficient technologies. A lot of people are talking about carbon footprint. So we would like to see more of green technology. And most often, novel thermal technologies and also non-thermal technologies uses a green approach towards that. So we use less energy, we use less water consumption. So it's very good in that front. Okay. So persuaded by the uniqueness of hurdle technologies in achieving gentler and efficient preservation approach and an optimized process. So again, another thing I like to focus on is the functional food that are increasing trend worldwide. So even in Malaysia, and I'm sure in Indonesia, so as the consumer are moving towards better lifestyle and good health, so the purchase intention of our people now has changed. So we need to produce a much more quality food more than ever before. Okay, so speaking of food preservation, so these are the novel thermal technologies that are available in the market now. Okay, we started off with ohmic heating, and I think you guys are also familiar with microwave, and there's also radio frequency and infrared heating. If we look at the source of this thing, okay, ohmic heating relatively was sourced by using electricity, okay, whereby when talking about microwave, we are looking into electromagnetic field, meaning we use electric to produce magnetic field. So these magnetic fields are used to treat our food. Okay. So another thing we have is radio frequency that are using sound wave as a source. Okay, so we will discuss this today, and for the next week we will be discussing on the non-thermal technologies such as S.TP. We also will be discussing on the pulse electric field or pulse light, ultrasound technology, irradiation, ultraviolet, co-plasma, and also ozone. Okay. So the first topic of the day is ohmic heating. So what is ohmic heating actually? So if you look at the diagram, sorry, oh my God, sorry, my slide was not moving just now. Okay, so this is the topic that we'll be discussing this week, okay, and the topic that we'll be discussing next week. All right, so the first topic of the day is ohmic heating. Okay, so what is ohmic heating? If you look at the diagram here, so ohmic heating can be differentiated with the conventional heating, where you mostly use heat or energy that is being transferred through the wall of your reaction vessel, or you can call it your pot, your kettle, okay, and then dissipated into the reaction mixture. So your heat energy or api, bahan bakar yang digunakan untuk memanaskan kita punya periuk nasi ataupun memanaskan air, that is what we call the conventional term of heating. Okay, so microwave heating is a direct and internal absorption of magnetron. So this one is called microwave radiation by the molecules present in the reaction mixture. So any food product that you want to use with microwave, you need to have a little bit of water content in it. So from that water content, it will absorb all this magnetic radiation, and it will gives out rotational energy within the food itself, and that rotational energy will be transferred into heat. That is how your food is being heated up using microwave. Using an inductive system, okay, so you would have Joule effect resulting from the induced electric current in the medium, and it can be either continuous or alternating field. So inductive is a bit like a pulse electric field, okay, if I may say, right? And the difference for ohmic heating is that the Joule effect resulting from the passage of alternating electric current. So it uses an electric current. So you would have two electrodes. So this is one of the electrodes, okay? And another one is here, and you put your food in between these electrodes. So these electrodes will give out electrical conductivity, and this electrode will be in contact with the medium, and that is how you treat your food, and by increasing the temperature also. So the advantages of ohmic heating is that any particulate food up unto 1 inch in cubic suitable for ohmic heating, meaning as small, as big as your commercial scale, it can be used, right? So the flow of liquid particle matrix approaches the plug flow when the solid content is considerable. Meaning, if you were to have your fruit juice, okay, fruit juice usually has what do you call the pulp? Inti pati, is it? Dr. Ibu Asri? Fruit juice has what we call the pulp, or orange juice. Kalau orange juice tu bisa dalamnya ada macam particles kan?
Yes,
Kalau
pulp.
kita minum,
Pulp.
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 Yes. So with ohmic heating, you can treat any food with such pulp. Okay. So for any other novel treatment later on when we discuss more, you will see the limitation of other treatment. So the advantages of ohmic heating is that you can treat food with pulp up until 70%. And the advantages of it is that the mixture can heat uniformly. So under some circumstances, okay, for instance, if the liquid possesses similar electrical conductivity, or it has a similar viscosity, conductivity, specific heat, and flow rate, then you can heat up your food uniformly. And the temperature are sufficient also for ultra high temperature, which is we can or you can call it UHT processing, which can achieve rapidly. And there are no hot surfaces for heat transfer, so it results in a very low risk of product damage from burning or over processing. So that's the best part about ohmic heating actually. And the energy conversion efficiencies are very high, and it has a very relative low capital cost. So even the maintenance cost is also very low. Okay, so it has the potential to provide shelf-stable food that is closely equivalent to those prepared from scratch. So that's the best part. So what are the designs? So the designs are basically quite simple, but you can manipulate them according to your food product. Okay, so usually it will consist of an electrode, a power source, and a means of confining food samples. So if you look at this diagram on the right, okay, you can see there's two electrodes. So there's one electrode here, okay, and another one would be here. And this is the confinement where you can put your food in. Okay, so if you look at the diagram below, it also has two electrodes. Okay, so the two electrodes is basically a requirement. You cannot have only one electrode. Okay, kena ada dua-dua sekali. So, and then you use thermocouple to detect the temperature or to control the temperature. So you don't want for it to be over processed, right? And an important design consideration is sometimes design electrode boleh berubah-ubah. You boleh guna electrode lebih daripada dua, boleh guna 4, you boleh susun dia cantik-cantik, atau you boleh guna 6, boleh guna 8, doesn't matter. You can use more than 2, but you need at least 2. Okay, and then the distance between the electrodes is also very important. Okay, sometimes when you put your food product inside and then you decide it doesn't kill off a lot of microorganisms. So what you can do, you can rapatkan you punya electrode kepada you punya makanan. So jadi makanan yang melalui celahan electrode tu akan di treat. Okay, and also heater geometry is very important. Heater geometry, kalau nanti I think saya ada gambar, tak ada gambarnya. Okay, heater geometry juga ada menunjukkan cara untuk kamu treat the food efficiently. Okay, and the frequency of alternating current, which is what we call AC. Okay, power requirement, current density, applied voltage. So it's very electricity focused, right? And important parameters are product property, electrical conductivity, and also density, specific heat, and viscosity. So the type of product and its property is very important to measure your effectiveness of your treatment. Okay, and having a very good electrical conductivity, which is a function of your food component, can help to again make your treatment efficient. All right, so electrical conductivity increases as temperature and also applied voltage increases, and it will decrease as solid content increases, right? Density are also very important. So when you are treating food using ohmic heating, your product cannot be too dense. It cannot terlalu padat atau terlalu pekat. Jadinya dia perlu macam agak-agak tidak terlalu cair atau tidak terlalu pekat juga untuk membantu electrical current to pass through your food product. Okay, so you look at starch gelatinization. So electrical conductivity can increase or can decrease with the degree of gelatinization, and suggests that ohmic heating can be used in the development of sensor to detect such gelatinization. And at the moment, I don't think kalau you familiar dengan equipment DSC, differential scanning calorimetry, it uses more or less the same heating treatment, okay, to detect gelatinization of starch. Okay. Apa lagi important parameters are heat generation. So rate of heat generation, electrical conductivity of the food material, and the way in which food flows through the ohmic heating is very important. Okay, so kalau kamu lihat kat sini, this is an experiment bila dia menggunakan ohmic heating at 90 volt, 120 volt, and 150 volt. So jadinya kalau you tengok mushroom stem, batang mushroomnya, dia lebih cepat absorb heat. But maybe mungkin sebab dia kecil. Okay, and kalau you tengok mushroom cap, dia agak lambat, agak perlahan gitu. Okay. So how do you model ohmic heating? So you tengok dari segi distribusi suhu. Okay, temperature distribution, kalau you use computational fluid dynamics software, that this is how they will come out. So you boleh, jadi kita boleh agak, kalau kita menggunakan makanan yang berupa seperti spherical begini, jadi dipotong 4 ya, jadinya sukuan gitu. So kalau dia berbentuk spherical, kamu boleh nampak dekat bahagian tengahnya tu nampak temperature distribution agak tinggi berbanding dengan bahagian tepi, bahagian luarannya. So that's the important part of using computer fluid dynamics software ataupun CFD. Okay, jadi kita sebelum kita menggunakan eksperimen, kita dah boleh predict bagaimana temperature distribution akan berlaku pada sesuatu bentuk makanan itu. So, kalau you tengok dekat sini menggunakan 400 volt ohmic heating, walaupun macam agak tinggi suhunya, tapi dekat bahagian dalam agak sejuk masih. So dekat bahagian luaran tu nampak temperature sudah tinggi. Okay, kalau menggunakan one step at 200 volt pun nampak bahagian luaran ni pun tak terlalu tinggi dia punya temperature, dia punya suhu. Tapi kalau menggunakan two step, lebih sejuk, lebih nampak lebih sejuk berbanding dengan just hanya menggunakan satu step saja method. Okay. So apa lagi yang you boleh menggunakan ohmic heating is how do you model the kinetic of microbial inactivation ataupun pematian microorganism dekat dalam makanan itu. Kalau kita tengok contoh, one of them tomato based salsa, okay, at a pH 4.16. Okay, kalau you gunakan frekuensi dalam lingkungan 60 Hz to 20 kHz and voltage dalam about 12.5, suhunya akan meningkat setinggi 90 degree. And the higher the frequency, the faster inactivation will be. And you will find that your microorganism will be killed ataupun dimatikan keseluruhannya selepas 71 dan 82 saat pada 100 dan 60 Hz. So, itu kelebihan menggunakan ohmic heating. Okay. Nanti boleh baca lagi kamu boleh study more on this data. So selain pada itu, kita juga tengok in terms of vitamin degradation kinetics. Vitamin is very important, especially in food. So one of the biggest or the majority markers is what we usually detect on is vitamin C. So when we treat our food with any food treatment, we measure the vitamin C. So jadinya bila kamu tengok degradation atau degradasi of that vitamin C semakin banyak ataupun lebih daripada 50% selepas kamu treat the product, so jadinya kita tak berapa recommend that food treatment because secara awalnya objektif was untuk you treat you punya produk untuk menjadikan dia selamat untuk dimakan, tapi dengan dalam masa yang sama, you punya quality itu tidak berubah, bukan? So jadi that's why vitamin degradation kinetics is very important. So in my previous study during my PhD, I measured the vitamin C degradation kinetics, and kalau menggunakan ultraviolet light, vitamin C dalam saya punya fruit juice berkurangan begitu tinggi kalau especially bila lampu yang saya gunakan tu terlalu banyak. Jadi kita panggil over processing. So kalau sekiranya kalau kamu melakukan degradation kinetics ini, daripada situ kita boleh tahu at which point kita punya produk sudah melalui over processing phase. Okay, antara aplikasi yang kamu boleh gunakan menggunakan ohmic heating. So antara aplikasinya adalah kita boleh inactivate enzyme. So enzyme ni ada banyak gunanya kadang-kadang dalam makanan, but sometimes we do not want this enzyme to exist in our product. Sebagai contoh, kalau dalam orange juice, you akan jumpa pectin esterase enzyme. So enzim ni semakin lama dia akan menceraikan pulp daripada you punya juice. So you akan dapat dua kondisi of you punya juice yang tak akan nampak cantik kalau kita marketkan di pasaran. Jadi selalunya we want to inactivate that enzyme. We want to kill off that enzyme because bila kita market ni kita punya food product ataupun kita punya fruit juice di pasaran, kita tak nak lihat itu separation of juice and dia punya pulp. Okay? And apa lagi yang you boleh gunakan ohmic heating is tomato paste production. By using the ohmic heating, although the temperature is quite high, but kalau you tengok dekat sini, it improves the food color. So the food color tidak berubah. And then another method or another aplikasi ohmic heating is extraction of essential oil. So you boleh extract bauan limau, you boleh extract curcumin, so banyak kegunaan of essential oil yang you boleh extract, and also enhancement of phenolic compound. Sometimes bila menggunakan ohmic heating, kita boleh nampak vitamin C itu agak tinggi sedikit daripada kalau kita bandingkan dengan conventional heating, menggunakan dapur gas kalau kita mau masak gitu. Okay. And also the very important thing is we can inhibit or kill off our bacteria. Okay, nanti boleh lihat lagi ya kalau macam antara fungsi kegunaan ohmic heating is kalau you treat you punya sausage, the sausage punya texture tidak berubah. Itu yang bagus dia. Okay. Apa lagi yang you boleh guna? You boleh guna juga untuk blanching process. You know, blanching process is macam kalau kita ada sayuran gitu, kita masukkan dalam air yang sedang boiling atau air yang sedang panas, and then kita biarkan dulu dalam masa tak lebih daripada 5 saat usually. Lepas tu kita masukkan dengan pada air sejuk pula. That is what we call the blanching process. This blanching process is to retain as much as possible the vitamin within the fruit or the vegetables that we blanch. Okay. Another application is evaporation. We can also use fermentation with ohmic heating untuk mempercepatkan kadar fermentasinya. We can also use untuk starch gelatinization or even to dehydrate, untuk keringkan dia punya produk makanan, ataupun boleh guna untuk extract, untuk keluarkan gula daripada sugar beet ataupun daripada soya milk. Okay. So ini antara commercialized ohmic heating yang ada di pasaran. Ini dikeluarkan oleh JBT Corporation. Okay. Sangat besar, nampak macam complicated gitu dia punya teknologinya. Tapi the main important part is this copper coloured pipe. Color pipe yang dia berada di tengah-tengah ini yang berwarna keemasan ini adalah di electrode. Adalah electrode yang kita gunakan untuk treat our food product. Okay, this is another ohmic heating technology that was commercialized by HRS technology. Okay, pun yang ini juga digunakan untuk fruit juice processing. This one is produced by an Italian company called Cambia Termico. Okay, pun sama juga menggunakan ohmic heating. Okay, future research direction of ohmic heating is we want to develop temperature measurement methods that are non-invasive. Sekarang ni, the moment yang menjadi punca masalah adalah kita agak susah untuk letak itu thermocouple in between electrode, especially when we are talking about continuous process. Okay, sometimes kadang-kadang electrode itu sendiri akan mengganggu ataupun thermocouple itu sendiri akan mengganggu the electrical wave that goes through your food product. Jadi kita tak nak itu berlaku. Jadi itu yang masih lagi ongoing research process. Okay, and also we want to develop model that correlate the process parameter and process design. Okay, to standardize the ohmic heating design and analysis and accurately quantify changes in process of product. Apa maksudnya gitu? Kita mau standardize the process of ohmic heating. Untuk sebagai contoh, katalah kan kamu mau treat orange juice. Kalau boleh kita mau keluarkan satu proses parameter yang kita boleh kata, okay, at 90 volt, kita boleh treat orange juice yang 50 liter, mempunyai 70% pulp selama 30 saat. Kita mau that process yang very specific. But sekarang ni tak ada lagi at the moment. So it's an ongoing research process. Okay. And we also want to determine the influence of temperature and electrical and also degradation kinetics of key pathogenic microorganisms. So research yang berlaku sekarang agak limited ya. So jadi bila agak limited, kadang-kadang kalau industri yang sudah membeli equipment, dia terpaksa melakukan dia punya own R&D, especially bila makanannya mempunyai pertinent microorganism yang belum lagi orang study. Okay. And then also we want to develop the knowledge that is necessary to quantify the effects of electrical field on the mass transfer property to optimize promising application of ohmic heating, including drying, extraction, blanching, fermentation, evaporation, and gelatinization. Okay, and we also want to quantify electrolytic effects particularly the minimization of electrolysis at low frequency with several novel process options. Okay, so that is the future direction. If you guys are interested after this to pursue your study, maybe you can use this as your keyword that you can use later on when you want to pursue your study. Okay. Masuk kepada subtopik baru, which is infrared heating. Infrared heating, ini one of the technologies yang ada sekarang ni yang telah dikomersialiskan. So selalunya infrared heating ni kita menggunakan temperature yang agak tinggi dan mostly digunakan untuk kita mengeringkan bahan, untuk mengeringkan kita punya food product. So what is infrared heating? So infrared heating berbeza dengan ohmic heating, dia menggunakan electromagnetic wave. So dia menggunakan electric field yang digabungkan sekali dengan magnetic field yang akan menghasilkan electromagnetic wave. Okay, itu dia infrared heating. So infrared technology is very energy efficient. It uses less water consumption and also environmental friendly compared to conventional heating. And it is also characterized by the homogeneous of heating, okay, meaning you would get makanan yang dipanaskan secara seragam, high heat transfer rate, low heating time, and low energy consumption, and also you would get improved product quality and safety. So infrared technology is used in many food manufacturing processes such as drying, boiling, heating, peeling, polyphenol recovery. So freeze drying can also use infrared, antioxidant recovery, microbiological inhibition, sterilization of your grains, bread, roasting of food, manufacturing of fruit juices, and also cooking your food. So what is infrared? Okay. When you're talking about electromagnetic wave, so there's a lot of electromagnetic spectrum. So you would have your radio, you would have your microwave, infrared, visible, ultraviolet, X-ray, and also gamma ray. Okay, so infrared, dia duduk in between ataupun di antara visible spectrum dan also microwave spectrum. Jadinya dia punya wave tu agak berbeza daripada microwave, which is microwave ni agak macam panjang ya wavelengthnya. So kalau infrared a bit short, bila dia a bit short, then it would have very high energy. So bila high energy means it also have a very high frequency. Okay, so when we compare between ultraviolet and infrared and also microwave, you look at the molecule conformation. Okay, so the molecule conformation for ultraviolet, the molecule most often will dissociate. It will break down. Dia akan pecah daripada dia punya covalent bond or even hydrogen bond. Okay, but for infrared radiation, the molecule inside your food product will vibrate. So when they vibrate, they would accumulate a lot of energy, and this energy will dissipate as heat because tenaga ataupun energi tidak boleh dimusnahkan atau dibuat baru kan. Jadi ini dia akan transfer into another form of energy. Okay, so for microwave, the molecule inside your food product will only rotate. Okay, they will only move about within dia punya conformasi. So the mechanism is actually depending on the three types of wave. Okay, so you would have NIR. Usually saya rasa NIR ni agak glamour ya in comparison to yang MIR and FIR. Okay, NIR is a wavelength that range between 0.75 to 1.5 micron meter at a temperature below 400 degrees C. So NIR is somewhere around here. Okay, dan kalau tengok dekat bahagian bawah diagramnya, NIR is sebelah kiri. Okay, and then mid IR or medium is a wavelength between 1.4 to 3 micron, temperature between 400 to 1000 degrees C. But this far infrared ray between 3 hingga 1000 micrometer at a temperature above 1000 degrees Celsius. And another fun fact is that 66% of our solar radiation is actually infrared. Okay, so it's either whether it's NIR or FIR, that one I'm not so sure. Okay, but it is based on infrared. So another mechanism is that infrared can penetrate into your food product. So once it's penetrating into your food product ni mempunyai molecules kan. So this molecule, especially when talking about water, bila dia absorb this wave, dia akan emit energy. So dia akan move about. So this moving about or vibration that would caused by a frequency of 60,000 to 150,000 megahertz, and thereby will cause heating. And electromagnetic radiation will cause thermal movement of the molecule, but conversion efficiency is highly depending on the frequency. Semakin tinggi frekuensinya, semakin tinggi thermal movement of your food product. And kalau kita tengok, kalau kita lihat diagram ataupun gambar di tepi ini ya, kalau saya tengok, saya tunjukkan. Kalau kita tengok dekat sini P dan L, which is protein and lipid, the absorption of that wave is very high in comparison to sugar. Okay, and kalau water pun it's a bit low. Okay, so the efficiency of converting absorbed energy into heat is great at high wavelength in infrared radiation, so that electromagnetic radiation produced by infrared deepens the food by few millimeters. Okay, so jadinya the only problem for infrared is macam mana dia mau kita penetrate food product kita. Kalau untuk semi solid dan untuk liquid tak ada masalah. Tapi kalau untuk solid dia agak bermasalah sedikit sebab kita tak tahu berapa banyak of that food product can absorb the wave. Okay. So if you look at the relevant food component, okay, so you have your water, sugar, which the chemical groups are hydroxyl group, and lipid, sugar proteins, lipid protein, okay, and different types of protein, and you will have the unsaturated lipids. So the absorption wavelength, water can only absorb is about 2.7 to 3 micrometer sahaja. Tapi you tengok pada lipid, it's a bit high. So jadinya kalau food product itu mempunyai tinggi lipid atau tinggi lemak atau tinggi protein, dia lebih senang untuk absorb the electromagnetic that was given out by the infrared heating. Okay, so most infrared radiation is absorbed by thin layer of organic matter and water. So heating is very superficial. Apa maksudnya gitu? Dia temperature untuk makanan tu tak akan naik terlalu tinggi. Walaupun tadi kalau you lihat daripada sini, dia mention 400 degree kan. Kalau 400 degree tu kalau dia absorb semuanya untuk oleh makanan sudah hangus gitu. Jadinya kalau dia just lebih kepada dia absorb oleh surface saja. So only on the surface you will look like it's been cooked, nampak macam dimasak gitu, tapi belah dalamnya tidak diabsorb terlalu banyak. Okay? Itu yang bagusnya dengan infrared heating. So jadi the process of infrared heating is faster and the energy is transferred from the heating source to the food simultaneously. Right? So therefore you don't need any hot air drying. Okay? No, you don't need any other accessories. So the advantages. Kalau you lihat kan gambar yang di bawah ni, kalau you tengok conventional heating, usually this mass is your food. So kalau you letakkan heat terlalu banyak, you akan nampak kalau you punya food product tu akan mengeras gitu. Macam katalah you masak roti. Roti kalau you letak dalam oven, lama-lama roti tu akan mengeras kan. So kalau gunakan infrared, dia tak akan mengeras. Itu yang kelebihan infrared itu. Okay, so selain daripada highly energy efficient, less water consuming and environmentally friendly, it also feature a very low energy cost, and the size of infrared equipment is usually very small, so your maintenance cost is very low as well. Okay, the thermal efficiency of infrared is very high, so it is considered a very valuable energy source. And it also pointed out, okay, that infrared radiation did not have enough energy to harm or damage the DNA. Okay, kalau I think minggu depan kita akan bincang on ultraviolet. Ultraviolet is a non-thermal and you will see how the mechanism of ultraviolet itself, where it will damage the DNA of the microorganism. Tapi untuk infrared, dia tak akan damage the DNA. Apa yang dia akan buat lebih kepada mengeringkan ataupun membuatkan microorganism tu terlalu dehydrate sampai dia mati sendiri. Okay. The energy is directly concentrated on the material to be heated, and it also does not produce any byproduct or organic compound, carbon monoxide. So it's very safe. Okay. And it can also preserve vitamins, has very little flavor loss and no heating of the surrounding air. Okay, so the FDA also have indicated that infrared radiation can be used in food processing, but this one is not considered as ionizing. So nanti minggu depan kita akan bincang ionizing radiation pula. Ya, ionizing radiation that is menggunakan gamma radiation. So infrared radiation improve the quality of the treated product and also improve the safety of treated food. It also reduces the consumption of chemical, water, and increases the manufacturing efficiency. So macam mana pula untuk desainnya? So design infrared is very simple. Dia sebenarnya rupa macam lampu sahaja. Okay, cuma untuk menghasilkan lampu yang emit infrared radiation, kita perlu menggunakan sama ada electrical heaters ataupun gas fired heater. So but selalunya kita akan lebih gunakan electric heater sebab dia lebih senang untuk dikontrol, lebih cepat heating rate-nya dan lebih clean energy gitu. Okay, so infrared emitters are more flexible in producing required wavelength for a particular application. And infrared radiation can also emit wavelength ranging from short to long wavelength depending on the voltage applied to the emitter. So kalau you tengok gambar yang di sebelah kanan gini, so heat distribution with conventional heating, kalau you tengok dia banyak di corner of the food confinement, banyak duduk dekat bahagian tepi-tepi sahaja. So kalau dekat bahagian atas dia nampak temperature-nya about 26 degree C. Tapi bila turun ke bawah dia punya temperature-nya sudah 18 degree C gitu. Dia nampak tak homogeneous dan lagi satu menghasilkan cold spot. So ada bahagian makanan yang tidak terkena the energy, terkena heat tu, ada bahagian makanan yang terlalu banyak pula energinya. Ini kalau common kalau you gunakan microwave. Kalau you letak microwave, dalam microwave tu kalau you cuba panaskan roti, kalau terlalu lama, kalau you nampak nanti dekat bahagian roti tu walaupun dia rupa 4 segi, belah yang paling dekat dengan emitter akan lebih cepat hangus compared to yang jauh dari emitter. Tapi kalau kita gunakan infrared technology, distribution of heat is very homogeneous. Okay, and also efficiency of using electric infrared heater ranges between 40 to 70% in comparison to gas heater that only produce about 30 to 50%. Okay, so this is how you produce infrared technology. Again, dia menggunakan juga emitters, kita panggil infrared emitter, macam rupa electrode tapi sebenarnya bukan electrode yang dipanggil emitter. Okay, so this infrared connected to electrical, so daripada electricity itu akan menghasilkan electric current, bukan electric current, kita panggil electromagnetic current. So design yang lain, kalau nampak dekat sini, so ini kita menggunakan FIR untuk mengeringkan kita punya food product. Okay, so yang bawah ni kalau kita gunakan gas instead of electricity. So ini cara ataupun schematic diagram dia. And this is a microwave yang sudah dibuat sesuai menggunakan infrared lamp. So dia lebih efficient dan lebih homogeneous dalam menghasilkan energi yang pergi kepada semua corner of your food. Right? Another design is if you were to combine infrared with vacuum chamber. Okay, it's lebih efficient dan kalau untuk moisture rich product, your product will not dry off very easily. Okay, and yang gambar yang bawah dia menggunakan NIR heat source and also MIR heat source. So selepas NIR dia akan pergi kepada MIR heat source. So apa gunanya adalah untuk blanch carrot. So carrot tu akan mendapat macam effect of blanching menggunakan conventional heating, tapi the product tu masih mempunyai hasil nutrisi yang tinggi. Okay. So important parameters that you need to know. Talking about irradiation, you would also know that any radiation can be reflected. So how much is being absorbed and also how much is being transmitted or being as a waste. So usually kalau kita membuat salah satu research itu, kita perlu ukur berapa banyak makanan itu absorb infrared kita tu, in comparison tu berapa banyak yang that is being reflected dan berapa banyak yang terbuang. Okay, so berdasarkan apa yang diabsorb, kita boleh improve the parameters and improve the technology and also kurangkan juga energy waste. Okay. Another important parameters is dissipation of radiant energy in the form of transmitted heat. So this will produce a warming of the surface of the food, and the penetration depth depends on the thickness of your food product. Jadinya kalau menggunakan infrared ni, kita kalau boleh jangan produknya terlalu tebal, okay? Especially kalau kita gunakan infrared heating untuk mengeringkan produk. Okay, jadi bila kalau kita nak keringkan produk tu, kalau boleh produknya kena nipis-nipis saja and kena susun homogeneous, maksudnya uniform. Tak boleh you letak sekejap banyak, sekejap you susun macam gunung, sekejap you ratakan dia macam jalan, so nanti dia tak homogeneous. Okay, infrared absorption is also differentiated according to the protein, fat, carbohydrates and water content of your food. So depending on the amount or the composition of your food product, if it has high water, then that means the absorption of the infrared will not be so efficient. But in comparison, when you have very high protein or fat content of your product, then the absorption is very good. Okay. So apa kegunaannya adalah ni antara kegunaan apa tu infrared heating. Okay, so you can use on dough, you can use on bread, you can also dry up your biscuits and also keringkan grain such as gandum. Juga you boleh keringkan juga carrot ataupun you boleh buat blanching. So there's a lot of usage and you can use with it. Okay, so the most important thing is if you were to use it for drying, you can reduce the processing time. Okay, enzyme inactivation, it can improve the food safety and inhibit lipid oxidation and also extend the storage period. Okay, and other parts is physicochemical property modification. Let's say if you want to modify your starch, okay, from less swelling to bigger swelling. So when you put in water, it will swell up a lot. So using infrared, you can do that. Okay, even you can cook your product using infrared, right? Another application is this is what we call particle analysis technology. So by using NIR, you can analyze your product, the quality of your product, sometimes the composition of your product using a real-time data analysis. Okay, how do you do that? Is by using a NIR probe or NIR sensor. So dari situ kita boleh keluarkan what we call model predictive control, and then kita boleh analyze the content or composition of your product. So commercialized IR heating, saya terlupa untuk letakkan nama company ni, tapi this is an infrared tray dryer. So what does it do is to dehydrate your food product. So kalau you mau buat keripik pisang ataupun keripik buah-buahan, you can boleh menggunakan infrared dryer, which is very good in the sense that we retain as much of the nutritional composition. So macam mana cara penggunaan this dryer is that it has a blower, it has a heater, and you have your air in and the infrared will be at the top. So what does the air will do is basically to dissipate, untuk menolak apa yang terlalu banyak yang berkumpul di dalam tray ini. Jadi your food product will not be over processed ataupun burn. Okay, tak hangus gitu. Alright, another is commercialized IR heating. And this is, if I'm not mistaken, a company in India. They call it Karim. So it has a multiple phase. Yeah, so the first phase, your product will come in from the left side. So it will be given in IR, infrared heating. And then as it moves further, they will go through what we call the microwave heating. And then as it moves towards the end of the line, it will undergo another IR heating again. So the machine looks something like this. Jadinya loading from behind, so dia akan unload from here. Okay. So future research direction. So basically it needs substantial in-depth studies and investigation into the possibility of using it in the manufacturing of sensitive food. Okay, so sensitive food that is sensitive to heat, we need a lot more study on it. Infrared in the future will be exploited to extract essential oil, distillation of water, heating food by continuous method, and expand their integration in other advanced techniques such as electrical field, magnetic, and also ultrasonic thermal in addition. So using IR is also desirable to sterilize your food packaging. Okay, so before you package your food product, it's good that we sterilize our food packaging. Okay, so we can use IR with it. So the study the integration of radiation infrared with reflectance window drying for the purpose of increasing energy efficiency. So another thing is kita perlu lebih banyak lagi research on food product untuk lihat on the uptake effect of the physical chemical properties, on the sensory property, on the nutritional quality. The interaction between this process and also the product needs coherent experiment in order to gain more knowledge. And also kita nak juga what we call standardization. It's good nanti later on, jadi kalau apa-apa industri makanan mau menggunakan infrared, dia hanya perlu rujuk saja kepada punya scientific article, jadi dia dah tahu what is the critical parameters that they will need to use. Okay. Another subtopic of the day is radio frequency heating. So this is a commercial type of radio frequency heating. So radio frequency heating is also known as dielectric loss heating or dielectric heating. Why does it call that? It also uses electromagnetic field. Okay, kalau kita tengok, kalau kita lihat on the frequency spectrum pada gambar di bawah, radio frequency berada pada sebelah kanan sekali. So kalau kita ingat tadi the whole spectrum tadi, radio frequency mempunyai wavelength yang lebih besar daripada microwave dan infrared. Jadinya bilanya lebih besar, dia punya frekuensi lebih rendah. Kenapa dia buat macam tu? Sebab pada pandangan mereka, bila frekuensi lebih rendah, kita akan dapat power yang a bit rendah juga. Jadi kita boleh avoid overprocessing. Jadi kita nak what they call gentler heating ataupun cara masakan yang lebih lembut gitu. Jadi so the use of radio frequency between the 10 and 50 megahertz is the most important and promising modern heating techniques. So radio frequency as a heat source was first described in the middle of 20th century, was used to melt frozen food and to process and preserve meat products. Okay? So radio frequency heating is basically electromagnetic energy that is being transferred directly to the heated product. And the longer wavelength of radio frequency compared to microwave are able to penetrate further into the food product, resulting in even more heating. So itu antara objektifnya. Because tadi kalau kita lihat in terms of infrared and also microwave heating, limitasinya adalah penetration of electrical wave or even the sound wave ada pada makanan. Jadi pada pendapat mereka menggunakan radio frequency, bila wavelength itu agak panjang, jadinya dia akan absorb lebih banyak. Okay. So electromagnetic heating categorized by its ability to to generate heat inside liquid material by polarizing the guidance of polar diodes such as water and force movement of ion. So kalau menggunakan radio frequency heating, you perlukan makanan yang lebih banyak air di dalamnya. Okay. So in this way, it limits the limitation that was imposed by the conventional heating. Okay. And electromagnetic heating process is relatively very quick and takes place through transmission of electromagnetic energy directly to the product. And heat is generated within the product without the need for heat transference in contrast to conventional heating. Jadinya kalau you tengok radio frequency heating mechanism pada gambar di bawah, kalau you lihat molekul dalam makanan itu dia akan oscillate. Maknanya dia akan bergerak antara satu sama lain. And kalau you lihat juga untuk radio frequency dia sama macam ohmic heating just now. So dia perlukan elektrod. Okay, dia memerlukan elektrod, dua elektrod. So daripada electrical power dia akan pergi kepada elektrod ini, dia akan menghasilkan radio frequency. Okay. So another mechanism is the range of frequency that is being used between 10 to 50 megahertz. The bound water in food ataupun kandungan makanan, kandungan air di dalam makanan, water content, play a very important role in dielectric heating in the frequency range between 20 to 30,000 megahertz. So when bila makanan tu mempunyai lebih air, dia exposed to alternating electrical field and dielectric heating will happen. So the polar molecules have electric dipole moment and the negative and positive charge centers do not align. Okay, so kalau dilihat gambar bawah ni nampakkan positif dan negatif ion tu akan bergerak-gerak atau berpindah randah, berjalan-jalan antara dua elektrod ni. So apa yang berlaku adalah what we call dipole rotation. Okay, another thing yang akan berlaku juga adalah polar molecule ini dia akan rotate, dia akan berpusing-pusing, berputar-putar. Itu dipanggil dipole rotation. And satu lagi dia panggil motion of this associative ion ataupun ionic conduction. So dua perkara ini adalah sangat-sangat penting dalam menjadikan radio frequency treatment very efficient. Okay. So advantages, of course, is much dia lebih energy friendly ataupun environmental friendly because it uses less energy. Okay. And the most important part is that the electrodes do not contact the food directly. Okay, it's not macam ohmic heating sebab itu yang membezakannya antara ohmic heating. Walaupun dia menggunakan elektrod, tetapi food product itu tidak mengenai antara elektrod itu sendiri. Kalau kita tengok ohmic heating macam ibarat kita rendam di elektrod dalam kita punya food product. But kalau untuk radio frequency tidak. Okay. And teknik ini boleh digunakan pada liquid dan solid food. And the wavelength of radio frequency is much higher than microwave. But because of the capacity of radio frequency power to penetrate deeper into food, the heat is generated inside the food and distributed evenly. Okay. So kalau kita tadi kita lihat infrared dia punya temperature-nya agak tinggi tapi dia hanya duduk pada surface sahaja. Pada dalam-dalam makanannya tu tak berapa penetrate ke dalam-dalamnya. Okay, kalau untuk radio frequency dia akan penetrate lebih dalam. Jadi penetration depth about 20 cm can be resulted by using a radio frequency of 27 MHz. Okay, and the affected diameter was also greater. Okay. And satu lagi kelebihan radio frequency adalah construction of large scale radio frequency is easier dan it improve the quality of the final product. And of course, since radio frequency does not contain magnetrons like microwave, so it is very less expensive than microwave and it will also ensure lower maintenance cost. Okay. So ini desainnya menggunakan dua elektrod juga, okay, tapi the food will not be in contact with the electrod. Okay, so RF radio frequency heating system consists of alternating voltage source. Okay, you would have capacitor and also two electrodes that will be connected to form an electric circuit for an dielectric heating system. Okay, so non-uniformity in radio frequency may cause damage to the product and package. So to solve this problem, a lot of industry they use hot air or even hot water or even saline water, okay, to improve on the uniformity of the heating. So another method can also be used is rotational device. Macam agar jadi produk tu akan berputar-putar gitu. And then agitation, maksudnya mixing process, and also can use pulse mode, okay, to improve the uniformity. CFD juga boleh digunakan dalam eksperimen lebih kepada untuk predict uniformity of heating process using radio frequency. Okay, and CFD can be able to understand the new test strategy, the mechanism, parameters optimization, and also determination of the best condition of radio frequency to treat your food product. Okay, so this is cara-cara ataupun confirmation on how you can penyusunan elektrod itu sendiri ketika food is being treated with radio frequency. So either you can use elektrod atas dan bawah macam ni, ataupun maybe you boleh gunakan elektrod dalam bentuk berbola macam ni. Okay, dia akan menggunakan zigzag conformation, atau you boleh menggunakan bola yang berupa begini yang akan menghasilkan elektrod juga, electrical wave. Okay, so this is antara cara untuk kita tinggikan uniformity of heating method. So kalau kita lihat in terms of this design, ada 4 design kat sini ya. Kalau di sini kita panggil direct design. So you would have your infrared camera, you would have your heated zone. So your RF or radio frequency applicator would be here. So this is a sample. Then kita boleh gunakan in terms of parallel plate. This is the 3D view. So electrode will be here, kiri dan kanan. Satu cara lagi kita panggil the 3D view. Kita boleh hasilkan electrode yang ini electrode ya, ni electrode yang warna orange ni. This is electrode, and this is another electrode. Jadi dia akan hasilkan radio frequency yang berbentuk rainbow gitu. Okay, another is kita panggil direct contact applicator. So this is the 3D view of you punya electrode. Okay, this is a CFD analysis. Okay, just to predict. Let's say if you were to use radio frequency on egg. Okay, ini telur ya. So this is ZX plane, this is XY plane, and this is YZ plane. Sekarang kita tengok in terms of cara penggunaannya tu macam kalau static, dia punya heating tu tidak homogeneous. Kita akan nampak pada belah kanannya lebih panas comparison tu pada belah luaran ataupun belah dalaman. Jadi apa yang diorang menggunakan kita panggil rotating plate. So your food product put onto a rotating plate. So they try to make it as homogeneous as possible. Okay, kalau lihat kat sini adalah titik panasnya ada belah sini, tapi masih boleh dikurangkan lagi. Okay, so that's the best part of using a CFD to predict the homogeneity of the heating product. So this is one of university's experiment. So they use electrode at the top and the bottom to treat white pudding. So this is the white pudding, ni electrode-nya. So dia menggunakan air. So air tu akan mengelilingi white pudding ni untuk homogenize the heating process. And then this is another method of using CFD to predict. Let's say if you were to use this is electrode, another electrode ini. So ini akan yang terhasil direct heating. Okay, kalau direct
Excuse me, Miss Nadiah. I think the connection is not.
Ini yang agak merah, yang ini pun juga, tapi ini
Hello, Miss Nadiah. Can you hear me? The connection is not good, I think. Terputus ya sepertinya ya, Bu Nadiah.
Iya Bu, udah ini kayaknya
Uh-uh.
terlempar dari Zoom.
Terlempar kayaknya ya, sebentar
Iya.
connect. Oke, mungkin sambil menunggu Bu Nadia kembali lagi, mohon disiapkan gitu ya beberapa pertanyaan nanti terkait dengan paparan beliau. Bisa dalam bahasa Inggris, juga dalam bahasa Indonesia ya. Sebenarnya sudah beberapa materi sudah kita berikan di perkuliahan sebelumnya. Namun ini bisa lebih kalian eksplor lagi mengenai desain atau mungkin ke aplikasinya. Karena beliau dari basicnya food ya. Ini beliau masih typing, ini belum terkirim ke saya. Ini masih ada ya mahasiswanya ya. Jangan tertidur nih. Oke, mungkin Ibu sedang mencoba untuk reconnect. Kita break dulu aja 5 menit ya. Mungkin bisa minum atau yang mau ke belakang. Silahkan break dulu 5 menit.
Bu, maaf Ibu.
Iya Bu, Dokter Nadiah.
Maaf,
Iya,
apa nih
oke.
lainnya tergandala sekejap.
Apakah akan dilanjut atau break dulu Bu? Mungkin biar jaringan internetnya sudah stabil.
Betul-betul.
Oke, oke.
I think yes, the internet is not stable. But the student now on 5 minutes break, is it?
Yes. Oke, oke.
Okay.
We will
Okay.
check
Alright.
after 5
Terima
minutes.
kasih Bu.
Yeah.
Okay.
Okay, student, I think the 5 minutes time break is over. We will continue again. Okay. Yeah. And one information for students, you may fill the attendance list in the chat Unpad. Thank you. So please, Dr. Nadiah, you may continue your lecture.
Terima kasih, Ibu. Okay. Just to continue, I'm sorry for the internet breakdown just now. Okay, so this is the other design that will uses radio frequency. Okay, you can use water bath for treatment of your food. So this would be your generator, electrode voltage control loop would be here, and your electrode is still within the confinement of your food product. Other design, this one, if I'm not mistaken, is using vacuum in tandem with the radio frequency. This one is using hot air in tandem with the radio frequency. Okay, the whole reason is to increase the efficiency of drying process. Okay, so important parameters is for you to be able to measure the ability of food to store electromagnetic energy, and thus to measure the property of food material to dissipate or to let go of the electromagnetic energy. You don't want any food product to retain any electromagnetic within your product. Okay, so the temperature and frequency play a very important role in both in the dipole rotation and also the ionic mechanism due to an increase in the movement of molecules by increasing frequency and also the temperature. Okay, so there are other many factors to have that is very important to have radio frequency heating uniformity, such as physical properties, dielectric properties, thermal, the distance between the treated product, and also your electrode, and chemical properties of your medium, and engineering design of your radio frequency heating devices. So if you look at the picture down below, it's basically the top surface temperature distribution comparison between first and second batch of cumin samples using the same radio frequency heating time. Okay, so the first batch would have a very high energy. Okay, if you look at this, it is almost up to 115 degrees Celsius. Okay, that is the surface of it. But if you look at the second batch, the energy dissipates. Okay, the energy that was being absorbed has already dissipated. It has already been released to the surrounding air. So you would have a lesser energy value of maybe around 60 degrees C. So applications of radio frequency is a lot. Okay, one of them is heating of bread, which is to improve the texture, inactivate microorganisms, and also prolong the shelf life. You can also use it to blanch your vegetables, inactivate pertinent enzyme, increase vitamin C level. And you can also use it for thawing frozen eggs, fruits, vegetables, and fish. Okay, and it will come up with a minimal discoloration and also loss of flavor. So it also decreases the thawing time and energy usage. So another method or another application of radio frequency is drying of cookies. So you can increase the oven line speed, heat uniformity, and then temperature difference has no temperature difference. So space saving and control moisture content, resulting in completely uniform moisture profile. So that's the best part. Other things that you can use with radio frequency is to sterilize your packaged flour, okay, or we call it, I'm not sure how do you pronounce flour or flour. And then you can also sterilize dry fruits with poor thermal characteristics, okay, such as coffee, nuts, beans, cocoa, and also corn grain. And it is able to reduce the moisture content from 6 to 1%, and with less drying time, and it uses less energy. Okay, in comparison, the drying time using the conventional dryer was about 150% longer in comparison to that of radio frequency dryer. So another thing is the application of drying is why, because you want the homogeneity of heating, greater penetration, that more stable control of product temperature with acceptable quality. And the time required to dry walnut using radio frequency was much shorter than that of vacuum and hot air drying. Okay. The temperature increased rapidly in comparison to vacuum and hot air drying because of the moisture content plays a very important role in the rise of the treated food temperature by radio frequency. Okay, and the radio frequency drying rate was faster. In addition, when you use radio frequency to dry your food product, it would have 3 drying rate stages. Okay, you would have increasing rate, you would have the constant rate, and you would also have the falling rate stages. But if you were to dry with vacuum or hot air, only constant rate stage was observed. Okay, so that's the advantages of using radio frequency. So radio frequency on liquid food, this is the method of it. Okay, so once you have done the pasteurization of liquid food using radio frequency, what you need to do is basically you need to validate. You validate the microorganism that was inactivated by radio frequency, and you compare them with thermal inactivation. And also you need to look into the food quality of radio frequency treated liquid food, especially on the sensory acceptability. Okay, whether your consumer would like to eat or to drink your liquid food that has been treated with radio frequency. Some of the commercialized RF heating are such as this, and again, I'm sorry I did not catch the producer of this equipment, but this is the schematic diagram of the equipment, okay, from the site. So basically, it uses a radio frequency shield, and it has a parallel plate capacitor, and this is the oscillator. So the food product would load from here, and it would unload here. Okay. And future research direction is consumer microwave may be replaced by radio frequency units that are much more efficient at cooking or warming food. Because at the moment, basically microwave is not used to cook food, but it's to only heat up food. What I meant by cooking food is that you are not talking about trying to cook Maggi for that matter, okay, or instant noodle. What I'm talking about is, let's say you are trying to cook biscuits or bread for that matter, okay? So you would like microwave to be much more advantageous, has many more applications rather than that. So current microwave have a single button control for different food that control the cycling of microwave over time. But however, imagine a radio frequency oven with similar single button control that can vary the frequency, duration, and cycling of radio frequency in order to maximize the quality and health benefit of a particular food. So we would imagine, instead of maybe calling it microwave, maybe we can call it macrowave. Okay, maybe because of the longer wavelength. All right, so I guess that is it for my lecture for today. So any questions so far?
Okay. Thank you very much, Dr. Nadiah, for giving us such informative and interesting presentation. And we can get a lot of insight from the thermal and non-thermal food processing, especially in ohmic heating, infrared, and also radio frequency. So now come to Q&A session. Well, is there anyone who want to ask? Please use the raise hand features in the Zoom, then unmute your microphone and camera. Okay, is that? Okay, maybe I will start to ask Dr. Nadiah. According to your presentation, I think a student now they can summarize the difference between ohmic heating and then radio frequency and also infrared drying. Because I think every processing has different heating mechanism and also has different critical parameters. So maybe in food engineering, we have a challenge to develop not only the process, but also the design equipment, and also to research more about the food properties in every food processing technique, especially for non-thermal. If thermal processing, I think we can improve from the conventional heating, and then we start to know the difference between the thermal and emerging thermal and conventional thermal process. But for non-thermal, there are many, I think, parameters that should be controlled.
Yeah, that's very true.
So how to develop, I think, or how we start this process? Is it should we start from research about food properties, dealing with this non-thermal, or we can start from the modeling temperature rise, or where should we start first, according to your opinion?
Okay. I think the first thing first, maybe you need to know which of the source of energy. Okay, let's say we are talking about radio frequency, it's an electromagnetic field, the source of energy. And then if we're talking about Ohmic heating uses electricity. So we need to firstly know the energy source, and from there you also need to understand the food composition. The very complicated things I think about food engineering is that we are dealing with food that has a lot of component inside. It's not like, maybe I'm just generalizing here. Let's say we're talking about civil engineering, where you develop cement mixture. It's just a matter of formulating, okay, how much cement you want to put in, and sand and water, so on and so forth. And basically you will get the cement. But the interesting part about food is that you will have different composition, and every different composition would give out different effects. So let's say if you were to use radio frequency on, again, example, fruit juice, okay, maybe the heating would not be homogeneous, and maybe the fact that it has pulp inside of it. So there's a lot of things, and you also have to consider the sugar content sometimes. Okay, sometimes because the sugar content itself can becomes a hindrance, or becomes an issue, a concern, in order to have higher efficiency of treatment. So in my opinion, before we come up with a new technology, we need to see first the energy source. We need to also look into the critical parameters of your food product, and of course the food composition itself. Yeah, only then we can develop, or maybe after that we can model, and we can predict what can happen with that. Okay.
Thank you, Dr. Nadiah, for your input. Okay, okay, student, is there any question? Let us know. Maybe start from, Fanny Deborah. Do you have any question? Oh, okay, we have one student who want to ask. Marvel, can you open your cam and unmute your microphone? Marvel? Please. Is there any, Marvel, if you cannot ask directly, you may type your question in the chat box. Oh, okay, Marvel, do you want to ask directly?
Yes, Miss.
Okay.
Apa sih tadi ngomong? I have a question, Miss. Everything could be used to defrost foods, or thawing process. My question is, does RF heating have any impact to the nutrition of the food? Thank you.
Okay. I couldn't hear your question clearly, but may I ask, Ibu, is it
Yeah,
is apa dia is every treatment will have an effect on the nutritional content? Unfortunately, yes. Okay, so but we have to measure. We have to measure the extent of the degradation, and from there we can control. So let's say if you were to use radio frequency at about 50 megahertz, and the effect of it is maybe in terms of degradation of vitamin C. And from the kinetics, we can learn at which point the degradation is not so much, it's lesser than 50%. Then from there, we can control the parameters that we use, maybe lessen the frequency to maybe 10 or lesser than 50, something like that. So yes, it will have an impact on your nutritional quality, but we can control it. So that's the most important thing.
Okay, Marcel, do you still want to follow up your question? Is it okay?
That's enough. That's enough. Thank you, Miss.
Thank you.
Okay, anyone want to ask again? Okay. Fanny Deborah, do you want to ask? Or maybe the head of the class, Benedict Shalom. Okay, okay, Benedict, you may unmute your microphone.
Okay, Miss. I have a questions about the future research directions. What are the most new? What's the newest innovations that the researchers have reached about the future research directions that you already show us in the presentation?
What is the newest technology?
The newest, yes, the newest innovations.
Innovation.
Yep.
Okay. May I go to the direction of non-thermal maybe?
Yes, please.
Okay. The newest innovation in non-thermal technologies, we are looking at into at the moment are cold plasma, nano cavitation, and also another name for nano cavitation is hydrodynamic cavitation, and another thing is those two. But when you look into the thermal food processing, I think the newest is what we call the MAC, microwave assisted thermal sterilization. Okay, what it does is basically it combines microwave energy and water. So you would have a chamber that would emit microwave frequency, and the water would help to propagate or to basically to distribute this wave of energy, this microwave wave. Okay, so that your food product can be run into that water and it will be treated. The advantages of this technology is that the food can be stored at ambient temperature. Okay, we are talking at room temperature for 6 months or more. So that is very, very good. Because why? When we are looking into our past experience dealing with COVID, everybody stays at home, no one's going out, and the food availability becomes very scarce. So this is where the food product that was being produced that can be kept at room temperature can be distributed to those in need. Okay, especially when we were dealing with natural disasters. So in Malaysia, we have flooding every once in a while, and that is quite bad. So food can be distributed to those in need. So I think that is why, regardless of, you may say, oh, everybody eats food nowadays. Food is available every day. You can cook at any time. But the reason why we actively involved in researching new technology to preserve our food is because everybody eats, okay? And the population is growing by the day. And in fact, if I'm not mistaken, the new statistics have shown that by 2035, we are looking into almost 7 billion people on Earth. So we're talking about 7 billion people, we need to produce a lot of food. So hence why we are at the moment where we are starting to question about our food security. So that's why the research about food technology, whether it's a novel thermal method or non-thermal method, it needs to go on, okay, regardless of whatever the advancement that we are facing now. Okay, I hope that answers your question, Benedict.
Yes, Miss. Thank you, thank you. And may I ask you one more question that where's the research take place? Is it on Malaysia or
Sorry?
where is the research take place?
Where does the research take place?
Yep.
Okay. If you're looking at Malaysia, we have a very small group that is working on non-thermal, but food engineering is catching on. Okay, even in fact in Malaysia, previously it was only my department, but now there are a few other universities that are also taking on the food engineering research. But worldwide, I'm looking into United States, Eastern Europe, Turkey, and at the moment, if I'm not mistaken, even South America in Brazil, they are actively seeking out into food engineering research. Okay, if you are looking more into references in terms of non-thermal, Brazil produces a lot of it. I think United States have slowed down quite a bit, but it's being taken up by Brazil and also Eastern Europe. Okay.
Okay, thank you so much, Miss.
No problem.
Okay, class, we still have time for discussion. Is there any question? Maybe from the mahasiswi? Because maybe Anissa Puspo, do you have any question? Novia Sandra Lestari. Okay, we will still wait the question. Okay, Miss Dr. Nadiah. In my previous study, in magister master student, I take my master in ASEAN Institute of Technology Thailand, and I'm working a lot about ohmic heating for orange juice mixed with carrot juice.
Okay.
At that time, in 2010, maybe ohmic heating is not much. The research about ohmic heating is not much.
It's not popular.
Popular, yeah.
Yeah.
And now, several times after that, we see that this ohmic heating spread widely for the research, and I see one problem when I do my research. The measurement tools and device, because I'm working with the electricity, AC, alternating current electricity, and I sometimes I get shocked,
electrocuted.
yeah, electroshock, and then also I have to use thermocouple coated with some material. It's made with silicon insulated material. So the thermocouple will contact with the food, but will not destroy the device. So, and now in Indonesia, we want to develop the ohmic heating, but we have difficulties to find this material, and also about the electrode. I working with stainless steel electrode, but now I read in many papers they have used Teflon coated or platina
yes.
coated. So it is very, I think it's very costly in Indonesia. And maybe according to your experience, how about in Malaysia? Ohmic heatings, they already developed well. I think I read a paper about essential oil extraction using
Yes, exactly.
from UTS.
A colleague of mine did that extraction of ohmic heating from dambai fruit and other samples also. Yeah, at the moment, to be very honest with you, ohmic heating on the sterilization or pasteurization of food is not actively being researched because we felt like it's already being how do you say it, macam dah terlalu banyak sekarang ni. Macam ibarat semua orang macam duduk study benda yang sama lebih kurang. Jadi that's why kita fokus lebih kepada essential oil. So at the moment yang ohmic heating yang ada dekat Malaysia pun, I understood your problem because it was previously faced by us also because the currency issue and it was quite costly. And kalau ibu mau tahu macam sekarang at the moment kita macam menghadapi financial issue in terms of grant untuk penyelidikan tidak banyak. Jadi macam everybody has to work in a team so that we can secure a bit more money so that we can buy a better equipment. So the one that we have ohmic heating now, if I'm not mistaken, it was Teflon coated, but again I need to ask my colleague for it. But you are welcome to come if you want to. Seriously, we can collaborate. And I can contact my friend and we can do some research about it because his work is mainly on essential oil. Then maybe we can start working on the food part, right? Okay.
Thank you, Dr. Nadiah, for the great opportunity.
No problem.
Okay.
I'd be more than happy to be your host. So please come whenever you have the opportunity.
Okay. Okay, thank you. Unfortunately, we cannot respond all the questions due to the limit of time. If you still want to ask to the Dr. Nadiah, feel free to contact her maybe by email or we can continue in the next session.
Yes, definitely.
Yeah.
Okay.
The lecture has finally come to an end, Dr. Nadiah. But before I close the lecture, I would like to draw a bit conclusion from what the speaker has presented. First, non-thermal treatment are among the most focused research area in the food sector due to the consumer demand for safe and nutritious food free from microbes. But the food product is exposed to non-thermal treatment for every short period of time and food is treated at ambient temperature. Since the exposure time is short and temperature is low, there are no chance to damage the heat-sensitive nutritional component of inputs. So no damage in food texture and then no change in formation of any toxic component in food due to the heat. So with non-thermal, I think the consumer will get fresh product with high nutrition and good color and good flavor also. But there are two sides with advantages and also come with some disadvantages as well. Yeah. Okay, I would like to express our deepest thanks and gratitude to all the students, I think to all the speakers for the inspiring and interesting presentation. Dr. Nadiah, thank you for joining with us to share your knowledge and hopefully we can learn something new and increase our understanding related emerging thermal and non-thermal. And we hope to collaborate more on research and maybe academic project in the future.
Definitely, yes.
Okay, student, we hope you find an informative and exciting lecture. Thank you for being a wonderful participant during this session, and I apologize if I make any mistake while moderating this event. And hopefully to see you again soon. And finally, let's give applause to our speaker. Thank you. And wassalamualaikum. maybe we can take a picture. Please open your cam, student. Okay, we will wait. Okay, Iqbal, maybe if you may open your cam. Fauzan, Tirta, Saumi, Maulija, and Cynthia. So, okay. Okay, ready, everyone? We will take a picture. 1, 2, 3. Okay. Okay, maybe one more time. Okay, I will. Okay, thank you, Dr. Nadiah. Thank you again for joining with us. Maybe we will have more session in the next week.
Really, I'll see you guys next week. Thank you very much, everyone. Have a nice weekend. Take care.
Thank you.
Terima kasih, Ibu.
Yes,
Thank you, Miss.
Assalamualaikum.
Thank you, Miss.
Salam.
Thank you, Miss.
Thank you.